Thank you, POUG. Thank you, everybody, for organizing this. I cannot describe how happy I am to be here, how unexpected it was to have this conference organized for real. I hope you recognize the music. It's from the bridge on the Kwai River, and it's a story about a prisoner camp in Japan with English prisoners trying to build a bridge based on Japanese specifications. They didn't manage to finish the bridge. The bridge wasn't strong enough and collapsed under the weight of the train. And they decided to make their own project and make a better bridge for the Japanese. So the English succeeded in creating this bridge. And the material was the same, the people were the same. What changed was the project and the knowledge. So this is relevant in every IT project, and I hope you will find it relevant also for this presentation. My name is Ludovico Caldara. I'm a principal consultant working for Trivaris in Switzerland. I am Italian, I'm not Swiss, but I speak Italian, French, and English, obviously, as you can infer. Now I'm speaking in English. I'm active in the community, but less known things about me is that I am a very poor volleyball player, but very passionate volleyball player, that I like mountains and I like metal. And if you know metal, you might ask also which metal, and this is too complex to explain. So just the very strange metal that nobody listens to. After a few years, I said it's better if I try to start learning some Polish, and so I learned Dzień dobry, I learned dziękuję, but also the most important things to survive here is poproszę piwo. So cheers. Oh, for the next year, perhaps. So my company, I will not spend much time, but it's a company based in Switzerland, Germany, and all, I would say, the German-speaking countries. We are quite a few colleagues, and we have quite a lot of projects. The scope is not anymore really the database, but they're much more like analytics projects and development, everything that is cloud, IoT, and all very hype words that I will not even try to understand because I'm really a database guy. And so we try as a company to make your life better for the customer and for everybody. So about the topic, it's about high availability. So everything that is data guard, real application cluster. And as you say in the title, it's about client configuration. Why? Because when you have new projects starting, I give an example. A developer asks for a database, and the DBA say, which kind of Oracle service do you need? And the developer doesn't know, so say, a normal one, the standard is just a normal Java application. So it doesn't know about real application cluster, perhaps it doesn't know about failover, etc. I say, just give me that one. And so the DBA, because it doesn't know the specification of the application, say, well, okay, just use standard PDB name, service that you should never use. Or I give you another example. It's not because you have real application cluster or data guard that you have a real failover ready application, because you have to do something more. And this is the purpose of my presentation. So I said, how can I try starting explain to a developer or to a public of developers and DBAs about the problem? And I say, let's start from the development point of view. It is, I said, how to connect to Oracle using Java. I started with the very basic stuff. And here, the question is, I cannot make this code work. And indeed, I find a lot of problems there. It's using the driver manager and not the Oracle data source. That is new, is not new at all, but it's what Oracle recommends to use. I see that they try to use a fake IP address instead of a server name. It might be a problem with DNS. Standard port, that's not a problem, but an SID is using an SID to connect to the database. This is not how you connect to a database. Not since Oracle 8, perhaps 8i, I cannot remember every time, but we are talking about the last millennium, 99, something over there. So for me, the problem, there are several problems there. Okay, the post is quite old, it's 6 years old, perhaps now it's 7, I cannot remember. Yeah, 7 years ago. And there are quite a few views. Now it's probably around 40,000 views. And the answer, the correct answer is, oh yes, it's because you're missing the jars, so you need to download the Oracle jars from here. This is the answer. And another one, the ads. Yeah, perhaps you want to download OJDBC 6 from there. That is not, again, the way that you, the version that you want to download. And this answer was from June 2018. So, wrong question, wrong answer to me. In this presentation, I will do some oversimplification because the topic is quite complex. So I assume that you have a few GBA and development skills, how to connect to a database, and you know some basic concepts like high availability, what is a failover, what is a connection to the database, and then you have a basic understanding of SQLnet configuration, so scan listener, services, and TNS naming resolution. And I assume always that you have a client that is at least 12.2, because the compatibility between client and server is important. But now if you download Oracle 19 client, you can still connect to 11.204 databases. So there is no reason that you're still using an old client. Upgrade your client, because now the problem that I see in every customer is we have to upgrade to 19C. And I say, yes, first you have to upgrade all your client, otherwise it would be not possible because they still run with client 11.201. It doesn't work anymore. So you have to upgrade your clients. And talking about the bridge, you have to practice for failures, because failures will happen, and is the way you react that make the difference. And this is a quote from Maya Hamm, is professional female football player. And I think that it's relevant to everything in the life, not only in football, obviously, not only in IT. What are the factors that influence HAs? There are too many. It can be network topology, OS type and configuration, database version, etc., down to the application design. So today we will focus on the last 3 points. I will not talk about network configuration, not that much about infrastructure, nor OS type or configuration. If you want more information about OS configuration, TCP timeouts, keep alive parameters, the ARP cache invalidation, there is a very good white paper from a colleague of mine, Robert Bialek, that wrote a few years ago for the DOAG, and you can find it if you just look for it, or you can try to use the QR code when you will get the slides. And the most important concept in everything that we'll explain is about database services. So I guess you all know what database services are, but are declarative endpoints. I would say it's a virtual name for an endpoint that you define. It doesn't matter which database you connect to, you go through the service and the service will point you to the correct database. You can have active-active, like real application cluster. You can have active-passive. Still, real application cluster is relevant. You can define it like this. Data guard, real application cluster, one node, etc. How you create it? Well, servicetl add service if you have a grid infrastructure, or DBMS service package, create service if you don't have grid infrastructure and you want to create the services using PL SQL packages. Both methods are valid. Both methods, you can specify several parameters for high availability. And this is what I will try to explain you today. The client many times needs to be configured properly. Even if you define the service properly, also the client sometimes has to implement something in order to be fully high available, and I will explain that later. Many customers still use parameter service names. Please don't use it anymore, it's deprecated. It's better to use startup triggers if you don't have grid infrastructure and put the creation stop and start of the service in a startup trigger. and always use your own service names, define it for role change. Okay, so depending if you are in a primary or a standby configuration, for example. Oracle recommends against using default services. Don't use SID, obviously. Don't use the PDB name because it's not for application connection that is being created. And don't use the default DB name service. The recommended connection descriptor, you can have it in a TNS format, or you can have it in an Easy Connect format, or LDAP, whatever. It doesn't matter. What's important is some parameters, like at the beginning, you have the parameters that define all the timeouts and the reconnect, retries, etc. for that connection string. And then if you are in a high available configuration, you have the first part that connects to the primary. In this case, I put address list because the scan is a series of addresses. It's not just a single address. So it's better to explicit that in the connection descriptor. And then I have the standby part. So primary and standby, it doesn't matter which one is primary and standby. By the way, naming primary and standby like this is bad. It's just an example to let you understand, but never use primary for the primary and standby for the standby, because when you do a role switchover, then you don't know anymore which one is which. And of course, the service name, okay? So this is the introduction, and then we go to the real stuff. What's important to me is that you understand what's planned maintenance and what's unplanned maintenance, especially because Oracle itself always use this naming when they talk about the features of high availability. So planned maintenance is when you have a session or many sessions that are already connected to a database, and planned maintenance is when you want to restart the instance for taking new parameters, when you want to do a switchover. The session already connected, and what you want to do is to restart instance one, okay? To apply the new parameters, for example. So before stopping and starting the instance, what you do obviously is a relocate of the service. So the new service is relocated, but what happened to the existing session? If I relocate the service, all the new connection will go here, but the existing session will not. The existing sessions stay where they are. And if I do a shutdown now, it will be like, it's going automatically? I don't know. It's like a shutdown for the session, and so it's unplanned failover for the session. So I need to make it planned. And what I have to do is to drain the session out of the data, out of this instance, and make them relocate to the other instance. Okay? How do we achieve that? We have to use a technology that is called fast application notification. It's been there since a while. How it works is when you create your service, you configure an Oracle notification service that is an external component to the database, and the ONS gets notified by the database about any change in the service. And when you connect, and you have to register as well to the ONS notification service. You register and say, I want to know all the modification that happened to the service, stops, starts, relocates. So please, ONS, whenever something happens, notify me so that I can close the session and relocate them, recreate them, reconnect on the new instance. Okay, so the application become aware that there has been a modification in the service and can reconnect. How do we implement this from the technical point of view? ONS is something that is included in the grid infrastructure, by default listed in port 6200. It's important to know that if you use 12.2 client, the client will try automatically to register to the port 6200 if you specify this parameter, notification true. So if I specify notification true when I create a service, I will automatically activate the notification for that service. And the client 12 connecting to the service will know that it has to register to the ONS, and it will do it automatically using the scan ports, the scan addresses. Then, if I have this, I can relocate with a drain timeout. I don't need to specify force anymore because I expect the application now to be aware that they have to relocate. But this is not all, because the application needs to do something from his point of view. So how it works? The application has to register. So as I said, this is something that is done automatically when I have a 12C client, but it has to register and then needs to listen for the event. So having a listener, fun event listener that waits for ONS notifications. And whenever there is a new event, this code will trigger. When I have a service down event, I handle the event. What's handling the event? I close my session and I open it again at transaction boundaries. What are transaction boundaries? Is whenever a session is over or is about to start, we are above the edges of the transaction. So it's safe to close and restart because I have no transaction running. Or even before starting any select also. Then, this is fast application notification. It's something that did manual modification to the application and also quite heavy for, I would say, just the management of the session draining. But there is another technology that is fast connection failover. And what's about? It's about putting intelligence, this intelligence of session draining, not inside the application, but inside the connection pool. Because if I'm using a connection pool, I have a Java or Python application using either Java connection pools or OCI connection pool in the case of Python. I might put the intelligence there so that the connection pool detects that for me and does the session draining whenever I have either a borrow or release of the connection. You know how connection pool work. I need to do something in the database, I borrow a connection, and then whenever I finish my select or my query, I release the connection. And so the connection pool knows that when I release the connection, my work is over and it can close the session and reconnect. So putting this intelligence makes the fast connection failover feature. So it leverages the fun events, and you have it automatic. You have it out of the box if you use universal connection pool. So if you download in the JDBC driver page, you download the ucp.jar and you use it as a connection pool. Or if you have a WebLogic, then you can use active grid link connection pool. Then you have the fast application notification management out of the box. You just need to enable the fast connection failover enables to tell the driver that just you want to use this feature. So it's, I would say, no change at all. It's just a minor change in the configuration. You can, sorry, thirsty. You can implement fast connection notification also with third-party connection pools, but there are some limitations about the driver version that is used. You have to include some jars that implement fast connection failover inside the connection pool. And yeah, and the connection pool needs to check the connection. So the connection pool needs to support this, by the way. The transaction boundaries is not only when I borrow or release a connection from the connection pool, but the connection pool can also have the intelligence to know that my connection, that my transaction is over whenever I do some calls like connection is valid. Because if I do connection is valid, I want to test if the connection is still there so that I can use it. So the connection pool can say, you are asking if the connection is valid. This is a good time to stop the connection, open it, and say, yeah, you have the connection. So session draining again, it's happening automatically. For OCI, it doesn't change. Just the configuration might be a little bit different because OCI connection pool you need to configure Aura access.xml. And yeah, basically it's just like that. And ODP.NET as well supports this. Okay. In 18C, what changed? the database itself can invalidate your sessions and close your session, even if the connection pool doesn't know about any fast connection failover. Let me explain that. Imagine I have a connection pool that is not intelligent with fast connection failover, but just does the is connection valid? So connection is valid to check if the connection is there. In 18C, the database itself can understand that I'm asking if the connection is valid, and the database itself can close the connection and say, no, your session has been killed. So the connection pool will say, the connection is invalid, I will open another session. And because the service has been relocated, it will spawn on the correct instance. Does it make sense? Yeah, thank you. And there are some tests that are already there. So whenever you do a select one from dual, Oracle 18C database will understand that as you are testing the connection, because it's a common test that we have in Tomcat, for example, or select count star from dual. You don't need to do that with the application, so it's obviously to test if the database is still there. Select one or begin null end. I don't know which application server does it by default, but apparently there is one. And you can also create your own. So you have a package where you can add a SQL connection test and say, whenever you see this query, kill my session so that I get an invalid connection and I will open it again. So it's a kind of hack to have a fast connection failover without using it from the connection pool size. How do we know if we implemented it correctly? It's just a matter of testing. You have to test, test, test. Would be better to have this automated as a functional testing in your pipelines if you can afford to have high availability for your development. And when your application is ready for planned maintenance, everybody is happy because you can do your maintenance during the day because you know that your application is completely transparent. Why session draining, or better, why not session draining? If you remember the slide where we had all the sessions connected to the first instance, if we don't use session draining, we stop the instance, we kill the sessions, and the session may react badly. The application may react badly. So this is what happens when you do unplanned maintenance as well, because you have a crash of the database, you have many sessions there, and they just have a failure. So in this case, I have an unplanned maintenance, the instance crashes, and what happened to the transactions? We had transactions, we had select, and yeah, we need to take care of them, okay, and need to know what we have to do. So the first technology for that is transparent application failover. That is for OCI drivers only. It's quite old. This is not even recommended anymore for Oracle compared to the new technologies that we'll see later. But what allows transparent application failover is to resume the queries. So if I was running a SQL query is a cursor that I start fetching. What happens if I use transparent application failover? When I have the instance failure, I will obviously lost my cursor, but the driver has the intelligence to say, I reconnect, I run the same select with the same SCN. I start getting the rows that are already fetched, I discard them, and then I keep fetching. So this is what transparent application failover is doing. And you specify failover type select, failover delay, and retry. Failover restore level 1 means that you want to reinstate the session state because otherwise you lose it. And I keep notification true always because I always want to have ONS notification enabled so that I can also use FAN for unplanned, for planned maintenance, sorry. And I can specify the same also at client side. So server side, I specify here. Client side, I can specify in the connection descriptor the same parameters. Not used anymore, why? Because you can still use fast connection failover. Well, not really. You can use on top of transparent application failover still fast connection failover. Why? because even if you have an unplanned maintenance, you get the notification from the ONS that say your session are died because the service stopped abruptly. So instead of trying to connect again and risk to have TCP timeouts, because there was a TCP connection there, the fan can just send the event to the application that can say, okay, there was a failure in the service, I reconnect. So it's the same principle, it's just make faster the failover for the application. The next one is application continuity. It's there since Oracle 12.1, so we are talking about 2013, I think. It's included, well, if you have active data guard or real application cluster or Golden Gate licenses, you can use it. But it's made of two components. The first one is Transaction Guard, that is a component that is included in Enterprise Edition and you can use for free if you have Enterprise Edition. What does Transaction Guard? Transaction Guard, when you ask to Transaction Guard to record the state of a transaction, it will give you a transaction ID and it will record the outcome of the transaction. So if there is any failure, I have the transaction ID and I can ask to Transaction Guard when I connect back, did you commit this this transaction or not? And Transaction Guard say, yes, I committed it, I don't have to do anything, or no, I didn't commit. Then I need to replay the transaction because it's something that I wanted to do. I've lost my transaction, I need to replay it again. And if you use application continuity, you have it out of the box. You have client-side replay driver. That is the second part of application continuity that make the feature transparent for you, that keeps the journal of the transaction. So when you activate application continuity, you say, I want to have a protected transaction with application continuity. The driver will automatically ask Transaction Guard to record the transaction and will keep a journal. So if there is a failure, the client connects again, asks to Transaction Guard, did it commit? No. Okay, then I have everything to replay again as a driver. So it's a lower layer compared to the application. The application doesn't know anything. It's done automatically by the application continuity. But I need to instruct the application in order to use this feature. And what I do is, if I have UCP, I don't need anything. Whenever I get a connection, it does it automatically. If I don't have UCP connection pooling, I have to explicit the fact that I want a replayable connection when I connect. Okay? So again, UCP automates much better application continuity for your application. At service level, I use failover type transaction that enable application continuity, but needs also to explicit the activation of Transaction Guard that I enable with commit outcome true. And yeah, still I want to restore the session state with level 1, and still I use notification true to keep, again, the fast application notification active for my connection pool or whatever. There are some mutable values that whenever I replay a transaction might change. So a sequence, for example, of a new value. So if I replay a transaction, I will get a different value. In that case, I have to give some grants to keep the sequence, to keep the dates, and to keep the sysGOID that I got during my transaction. So when I replay the transaction, I say, keep this value that I tell you, even if the sysdata has changed, but I want to keep that value, and you need a special grant for that, and you need to grant your application to do this. Transparent application continuity is, I would say, an evolution that automates application continuity, but from the server point of view. So it's a new feature in 18C that has been improved in 19C with support for OCI drivers. And it records everything at server side, okay? It doesn't need any application change. It doesn't need, I would say, anything special. The only thing is that in some cases, when you have the side effects, Oracle called them the side effects, perhaps the transaction is not possible to replay it. what are side effects are PL/SQL calls that use HTTP calls, REST calls, external tables, or whatever that might not be replayable the very same way. So whenever you have those side effects, you will get an exception and you will still need to trap it. But comparing to all the failures that you can have, this is very small, okay? And you can even say, I don't care in those cases, I get the exception because it's something special and it's not supposed to happen all the time. How do you enable it? Failover restore auto, failover type auto. This is how you enable transparent application continuity. Transaction guard must be explicitly activated. Notification true, again for fun. So if you create a service like this, in 19C, you have everything that you need to make planned maintenance and unplanned maintenance almost automagic for your application and transparent for the application. So to recap this, to drain session, planned maintenance, use fast application continuity or fast connection failover if you have connection pools. For everything that is unplanned, use application continuity if you want to have a full control, because there are lots of APIs that you can use to fine-tune the behavior for your transactions, or transparent application continuity if you want a very transparent feature that has quite a good level of automation, okay? Now, the last part is I want to spend something talking about connection manager. How many of you were here last year? Last year was about Simon. You remember that, huh? So connection manager is, I would say, a util tool to do everything in network redirection for Oracle databases. It's a kind of proxy for Oracle connections. There, in the classic behavior, what we knew since Oracle 10.9, I cannot remember when it was available, is just a transparent proxy for Oracle connection. You connect to connection manager redirects you, but the endpoints of the connection, talking about the TCP connection, well, not TCP, the SQLnet connections are the client and the database. So in the old version, if I connect to the database, I see that the client is the client. In the new version, Siman can work in transparent director mode and stop the connection with the client at Siman level and start a new SQLnet connection at database level. So the database will think that the client is connection manager. It doesn't think that it's the client anymore. And what's the purpose of doing that is that when I connect to Siman, Siman will give me, okay, you are connected, but make the connection only when it's really useful. So it's already doing some optimization there. And then Siman opened the connection to the database, okay? And whenever I have a failure or I stop the service, ONS will notify Siman because Siman has the ONS integration automatic. So it already does fast application notification handling at Siman level. And Siman stop the transaction, stop the session at transaction boundaries, reopen it. And from the application point of view, the connection is still there because the SQLnet connection was between client and Siman. Okay, so transparent in this case. I went quite fast or not? Yeah. And the connection, so is intact and the application doesn't need to do anything. So, because I have some time, I completely forgot to spin up my virtual machine. I don't even know if I still have it, the virtual machine. I forgot about it. It should be this one. Yep. Sorry for the delay, but yeah, I will take some time to drink some beer while the virtual machine spins up. It should be Should be this one. It's running. Sorry about it. Yeah. So oops. Okay. Demo. No. Demos, new features. Yep. No, we started later. We started at 10. So I have 5 minutes. It should be okay. And transparent application continuity. So I explained what I'm doing. I would like to show you a small demo about transparent application continuity because we have time. And now I never remember what I have to do here. I have to connect to TVD and CDB. So I need to start the TVD and CDB. Okay. So you're not saying what I'm doing. I don't need to explain what I'm doing. CDD was new features, high availability, transparent application continuity. Okay. So, can you switch? Oh. Okay, I will try to modify display settings again. Yep. Duplicate the displays. Yeah. Okay. So, let me get my mouse. Sorry. Because I don't know how to zoom without my mouse, so. Sounds stupid, but small problems. So, can you see it better now? And this one. Okay, so the first one, I'm connected as sys. I run this script. Out, perhaps. Okay, so I create a service where I have failover type automatic. That means that I have transparent application continuity enabled. And I start it, okay? And indeed, I see that I have in active services my TVD and CDB underscore TAC automatic, okay? So far, so good. Now, from another session, I run this. Okay, so I create a table from AMP. I update and I set the salary twice as it was. I do not commit. Here I have my Scott session, and I can see that it's there. And what I do now, startup 4. So I stop the instance badly, start it again. And of course, I expect that my session is not there anymore, correct? Just a little bit. Now, what I will do is to show you that the session is not there. And indeed, I don't have any session from Scott anymore. And here, what I do, commit. Will it work or not? Probably not, because I had a transaction, right? But it did. It's transparent application continuity using SQL+. Nothing special is there, it's automatic. It's cool, huh? Sorry? No. It's just new OCI drivers that handle this automatically. And because I connect to the transparent application continuity enabled service, the new 18C or 19C drivers handle this automatically. I need a new client. I cannot do this with 12C clients, of course. And so it committed correctly. And I can see that that's failed over. Okay, the instance is the same. I don't even have DataGuard. I don't even have real application cluster. It was a standalone instance, and it worked anyway. So the question is, what happened when you commit after the instance startup? Well, when the instance restarts, basically there is no connection anymore between client and server. But when I try to commit at the client side, the client is intelligent enough to reconnect, pass the information about which was the session, commit, and because I have transparent application continuity enabled at database level, the database know that that was the session. So the database replace the session for the session for the application. So replace the transaction for the application. And when I try to do the commit at the end, it works because it's a new transaction. So it will basically be a new transaction replayed automatically by the server. Yeah. Yeah. The client, what happened on client side, it depends if you are talking about your application or the driver, because the driver, what does is just wait for a new command from the application. And when the application tries to do the command, well, the driver knows that the session was transparent application continuity, it will do it will reconnect automatically. So the driver reconnect automatically. Any other question?
Yeah, in which form transaction guard keeps the track of transactions? Where is it kept?
I would say you can write a Python tool about it and let us know. There are hopefully some views that you can query about it. I've never tried to get this information, honestly.
It has to be somehow connected with the redo logs and then the log writer, because I don't see any reason.
I don't think so. I don't think so. I think it's another journal kept somewhere else, but I don't believe what I'm saying. The real answer is I don't know.
Okay, so
but it would be a nice question for the next time I will give this presentation.
For another sessions.
Yes. Yeah. One other question that I get sometimes is about what if the database needs to roll back a big transaction? In this case, you have an issue because you have the time to roll back this big transaction in order to replay the other one. So it will take some time. And depending on your failover retries that you have in your connection descriptor, it might work or you might get an error. Yes, one more question. Yeah, about licensing, the question was about application continuity and the license that is required. So the two component, transaction guard is free, but combination of transaction guard and replay driver is not. So this is application continuity, is the combination of both. If you want to use both, you need to have either active data guard or real application cluster or Golden Gate. Of course, Golden Gate includes active data guard, so you don't need both. Time out. Thank you very much. Thank you for coming. 5 minutes break.